Anyway, so with that, I think I'm finally coming back to do this. Yeah, so last week I kind of ran out of steam at the end of the session and said to myself, forget it. I don't have to do any of it. I'm just not gonna do it. So I didn't do it last week, even though it was on the agenda. I just, after doing the other things, I didn't feel like doing this. So let me. At this session, go through all the problem sets that I've skipped so far. We got 50 minutes or so remaining, and I'll have to split them. And let me try to do them in a way where it'll make sense being edited into separate clips. I think so. Editing them into like 15. About 15 to 20 minute segments. I think that's what's gonna make sense instead of having a 15-minute thing that includes all three. So I'll start with the problem set 10 and we'll go see where it goes from there. Let me just bring it up. So what I want to demonstrate is usually best because test is late. So what I want to demonstrate in the next, I don't know, 15 minutes or so is how to use ChatGPT as your virtual tutor. So the way you are using this way would be actually academically honest. The same way if you're getting help from LRC or a tutor you pay for yourself, that that's not academic dishonesty. Getting help is fine. Really, the main thing that matters is that you are learning, and so I got so I'm trying to do 3 problem sets today, so I got maybe 50 minutes for this one, and then I'll move on to problem set 11, 50 minutes, and then problem set 12, again 50 minutes. So it's probably going to be 1 or 2 question each set, and with each one I will just refresh each session. I am going to start out with this prompt. Hi, I'm working on homework set involving Faraday's law in a calculus-based engineering physics class, and can you help me? I'm really trying to learn the material because I have to answer my professor's questions at the oral exam next week. I mean, it might not be next week, but just making up a story for ChatGPT. So as it's responding, let me start. So it's gonna be 1 or 2 questions that I have time for. So let's try to pick a couple questions. Let's see. I think I want to try to find a question that's more substantive. One thing that I am curious is how well it answers questions like this. It's highly geometric. So yeah, let's try it. Alright, I got this question. The choices for current select and answer are about the direction of current through the 5-ohm resistor. And hoping with the prompt, ChatGPT won't just give me everything. It'll either wait for me to explain what I've done, or maybe give me a couple things to start with, maybe a statement of Faraday's law. So we'll see. Go from there. Yeah, apply Faraday's law, which tells you that induced voltage is given by basically the time derivative of the magnetic flux. And this sign is the one that you have to handle carefully to get the correct current. And yeah, Ohm's law, find okay. I think I have the derivative C attached. Does it look right? Do I want to make a mistake? Oh, you know what? Let me make a mistake. This is actually not a trivial derivative. So it's very plausible for someone looking at this to make this mistake. You say the magnetic flux is phi naught e to the minus alpha t times sine of omega t. And as you take the derivative with respect to time, it's really easy, I think, for someone to forget that this has time dependence too. You have to use product rule. But someone might just look at this sign and just go automatically to derivative sign. So with that mistake, someone might say minus omega using chain rule of on sine of omega t, phi naught e to the minus alpha t times cosine, wait, there's no minus sign, cosine of omega t. Um, so yeah, so let's paste this in and have ChatGPT correct me. I think it might just give me the correct answer. I've noticed that it doesn't always spot the mistakes I'm making. It just does the step itself and tells me the correct answer. We'll see. Ah, good, good, good. Yeah. It noticed it correctly read my expression and realized that I forgot the product rule. Yeah, that's good. Yeah, uh, first term. Yeah, second term is what I already did before. So really, this is one of the two terms. So I got the second term, and I didn't get this first term. So, um, yeah, I think so. Um, I think I can plug in the numbers myself. Can you help me with the direction of current? And numbers, once you have this correct derivative, then so you got phi naught, you got alpha, you got omega, and yeah, you can just plug in the numbers. So that'll give you the magnitude of voltage, and then current would be determine the sign of E, sign tell you whether induced current flows clockwise or counterclockwise. Yeah. Um, Magnetic flux through the loop is increasing. Induced current will flow in a direction that creates a magnet. Opposing it increase, flux is decreasing in a direction that, okay. Look at the calculated EMF for each time point. If the EMF is positive, the current follows. Um, I don't like this statement because it makes almost looks like it's implying that you could choose either way. Say counterclockwise. No, it's not an arbitrary choice. This setup has those sensors built in. So I would say this approach isn't what I would recommend. This approach is what I would recommend. That's actually how you can use the Lenz's law most directly. And the Lenz's law, as I say in the lecture, it's really a special name for this minus sign in Faraday's law. So if you're using Lenz's law, you've taken care of direction. You don't have to worry about this minus sign. So the way I say you should go is try to work this out graphically, spatially, and stick with that direction. So, so I'll say, can you check if I'll explain what I'm doing, and can you check if my explanation sounds correct? Because in terms of getting the right answer, I mean, it's multiple choice on a question where you have infinite number of tries. You can just try them all one at a time. So getting the right answer, that's not the hard part. It's actually understanding it. That is potentially the hard part. So for A, let's just start out with that. So at t equals 0, I think I can figure out correctly that sine of omega t is, or let me do this. I will make this mistake. At t equals 0, sine of omega t is 0. Now that doesn't mean the derivative is 0, because cosine of 0 is 1. But I might incorrectly think that the flux being 0 means the derivative being 0. So I might say does not noticeably flow. So I'll say for A at t equals 0, I think current does not noticeably flow because sine of omega t is 0 and the flux is 0. And it should tell me it's wrong, because I should be looking. What? Let's see if so let's put in the answer and see that it's wrong, and then see if ChatGPT will correct me on that. Thank you, but the system says our answer is wrong. Do you think there's a mistake in the question? Yeah. So yeah, you have to do the flux calculation. And so, one thing that will help you is before going into the detailed calculation, the phi naught won't change the sign. This exponential decay, it'll always be positive, and the derivative will also be, derivative will, no. It won't always be, at t equals 0, it's fine, because at t equals 0, this whole thing is just 1. So I think at t equals 0, this is positive, which means the magnetic field pointing out of the screen is increasing. So what you need is the induced magnetic field that's pointing into the screen to oppose that. And that's clockwise current. So clockwise current here means current here flows downward. Okay. So, yeah. Wait, is it negative? Did I make a mistake? No, that minus sign, I'm just gonna ignore it because it's a, I think I made a mistaken sign. Let me just write down the correct derivative just so that I'm not making unintentional mistake. So let's start with the derivative that I worked out. V naught, minus alpha E minus alpha T. Yeah, so ChatGPT is kind of getting mixed up right now because I think what it gave me as claiming to be the time derivative of the flux wasn't the time derivative of flux, but it was the induced EMF, one that has this extra minus sign in front. That's not the flux, that's EMF. And right now I'm just going to ignore the minus sign, and because this expression that it's using, it's not that, it's the one, this with minus sign. So I'm right that the flux at time equals 0 is positive, or the time derivative of it is positive. So using the derivative you gave me earlier, e bm dt, I have the time derivative of the flux at t equals 0 as plus phi naught times omega. That means we have a magnetic flux increasing out of the screen, so the induced magnetic field has to point into the screen, and the induced current that will give me that direction is clockwise around the loop, which will result in downward current through the resistor. Does that sound right? It should say yes, because that is the right answer. Yeah. Yeah. Don't get confused by that. That's one of the reasons you should read it through the ChatGPT answers, because sometimes it'll make those mistakes, and once you read it through and reason through, it can be easily spotted. You just have to be careful. Yeah, that one. Okay. Good. So with a B, I think it's still gonna be downward. And so let's see. Yeah. So with the actually so I chose this is going to be my justification, that omega is so much greater than alpha. So looking at these two terms, basically what will determine the sign is the second term. There's a small chance that this could, but given like cosine omega t, sine omega t being relatively same magnitude, basically whichever one has correct positive sign here, whatever the sign of the second term is, it's probably going to be the sign of the whole thing. So I'll say, so with omega being so much larger than alpha, I chose the direction of current to go with whatever the sign of cosine omega t is for B and C. So for B, let's work it out. For time equals 2.17 times 10 to the power of minus 2 times omega, 120 times pi, and take cosine of that. That's positive. So current flows down. Still same as the A answer. And C, I'm gonna make a mistake. Following this same approach again, what you're gonna get is 3 times the omega, 120 times pi, and then take the cosine of that, 0.62, so it'll say down. Again, B will probably be right, C should be wrong for B and C. And got current flows down for both. It looks like I was right for B but wrong for C. I don't understand that. Let's submit it to just. Wait, what? Okay, that's wrong. I think. Oh, maybe not wrong. So alpha being 1.5. Let's just plug in the full set of numbers. So 5 times 10 to the power minus Tesla times meter squared times minus alpha 1.5 inverse a second times exponential of minus 1.5 inverse a second times the time, 2.170 minus 2 times the sine of omega 120 times pi times t. 2.170 minus 2 plus omega 120 times pi times exponential of minus 1.5 times 2.170 minus 2 times cosine of 120 pi times 2. And that should be. So was that positive or negative? Incompatible units. Oh, let's see, alpha. Omega should have been entered as radians per second. So this divided by second. Minus. Did I? It's possible I made a mistaken reasoning on the first term. Second term is negative. So I think I made a calculator error. So doing the calculation on the second term, I should have correctly gotten that it flows up because it's minus here. I probably made a mistake on the calculator. Let's not dwell on that. Now, for the C, let me just double check one thing. So we are looking at now t equals 3 seconds. 3. And I thought the correct answer here is actually basically 0. We'll see. Maybe I'm misremembering. I guess that's not 0. Never mind. Yeah, so let me do it this way. So this should now be correct on B, wrong on C. And let me modify what I'm typing to ChatGPT for the just whatever sine or cosine omega is. And I got current flows up for B. And looking at the exponential decay, I thought that t equals to 3 seconds. So we would have currently does not noticeably flow, but the system says that's wrong. All right. Now, I think the question really should have asked for t, something greater, like 12 seconds. Yeah. Okay. What happens at t equals 3 seconds? And very small. Yeah, at t seconds to see that it's small but non-zero. Yeah, so I think the main thing is this 1.5 is not really large. So 1.5 times 3 is 4.5, and e to the minus 4.5 is not that small. E to the minus 45 would be different question from e to the minus 4.5. All right, I think that's enough time on this question problem set. Let me move on to the problem set 11 so that I get just a little bit of time with everything. And